This is sample problem 10.3. A sample of argon gas that originally occupied a volume of 14.6 liters at 25.0 degrees Celsius was heated to 50.0 degrees Celsius at constant pressure. What is the new volume? Okay, so this is, notice what's happening. The volume is changing, temperature is changing, but pressure is not changing. So this is an example of Charles's law. Okay. Charles's law says that the volume of a gas divided by its absolute temperature is constant. So a volume at one temperature, that ratio has got to be equal to the volume divided by the new temperature. That ratios are equal to each other. Okay? As long as the pressure is constant. And it says in here the pressure is constant. Now, there's one caveat to this. This has to be at absolute temperature. And so we're going to use the Kelvin scale. The Kelvin scale says that the Kelvin temperature is the Celsius temperature plus 273. 0.15, generally we can round that to 273, but I'll go ahead and use 273.15 for this calculation. So the main thing here is just identify what you're trying to figure out. The sample of argon gas originally has a volume of 14.6 liters. Okay, so I'm going to say the original volume, or V1, is 14.6 liters. At 25 degrees C, that means the temperature when the volume is 14.6 liters is 25 degrees C. So I'm going to add 273.15 to that. And I'm going to get 298.15 Kelvin. Okay? Then it says it's going to get heated to 50 degrees C. New temperature, right? So let's add 273.15. And what does that come out to? 323.15 Kelvin. Yep. Okay, so now we want to know what the volume is. So I'm going to call that V2. Okay? Original volume, original temperature, new volume. So let's come back to Charles's law. We want to find V2. So let's just multiply both sides by T2. So V1 over T1, if I multiply that by T2, that would be equal to V2 over T2 times T2, right? Multiplying both sides by T2. But that T2 on the right side cancels, so that's V2. So all we got to do is multiply V1 times T1, V1 divided by T1 times T2. So that would be V1 is 14.6 liters. Divide that by our temperature, 298.15 Kelvin. And then we're going to multiply that by our new temperature, 323.15 Kelvin. This is going to tell us that the volume of a gas increases. It expands if you heat it. If it gets hotter, it will have a larger volume. So 14.6 divided by 298.15 times 323.15, and you get 15.8 liters. Remember, we are not going to use degrees Celsius. No degrees Celsius for gas laws. Degrees Celsius will give you, sometimes it'll give you ridiculous answers. So for example, if I use a negative temperature, Kelvin scale has no negative temperatures. Or if I put in 0, what if it's 0 degrees C? The volume of oxygen gas does not go down to 0 if the temperature is 0 degrees Celsius. Okay, so no degrees Celsius in these calculations. use the Kelvin scale, add 273.15. And again, heating a gas at constant pressure, that's Charles's law. Heating it, we would predict that the volume would increase. In this case, it went up from 14.6 liters up to 15.8 liters.